Okay, quiet. Here we go. Make sure our mic is working here. Yep. Okay, I try every single time that I do an AP problem to model how you should be doing the problem. If you've never seen them before, I've seen them, but that doesn't change how I solve them. Like, I don't ever solve an AP problem by thinking, oh yeah, this is just like this other one, so I just do the same thing. I always solve the problem from the standpoint of read slow and careful, identify what concepts I need to be using. So they give me a formula for G, no new data there. I get formulas all the times in AP problems, so whatever, formula for G. They say F is G prime. Very interesting. Then they say find the integral of F. Well, you all need to have the following slogan memorized. If you don't have it memorized, write it down now so you can add it to your list of things to memorize. The slogan is, well, I don't see how to integrate because I don't have F. So instead of integrating F, I'm going to anti-differentiate and evaluate. So I feel like it's easy to memorize because it rhymes. Instead of integrating, so when you can't integrate, anti-differentiate and evaluate. Question. So I need the antiderivative of F. Well, I tend to get mixed up a little bit, so I make a little Daniker's chart. I say amount. I guess I'll put F there. But they said that F is the same thing as G prime. That means G prime would go here as well. There, I just unlocked the problem. Like, I just figured out what I need to do. Because raise your hands if you can tell me what is the antiderivative of F. Hands up. What is the antiderivative of F? Read the problem. You can do it. What's the antiderivative of F? Ariana?
G of X.
It's G of X. That's why I said, how many knew it? Point, two for Ariana. That's why I said, I read the problem slow and careful. I get to this point, and I'm like, okay, I'm supposed to find that integral. But I see no way to integrate. So, anti-differentiate and evaluate. But I don't know the antiderivative of F. So then I think, well, a Daniker's chart always helps me organize. Like, I keep doing it over and over again. Like, how many times do I write on the board? Amount, rate, like always. That unlocked the problem. I'm like, got it. This integral can be found by taking the antiderivative of F. The antiderivative of F is G. And evaluating G from 1 to 3. So now I simply do that. Don't forget, when you subtract multiple terms, you've got to have a big parenthesis there. If it were an FRQ, I'd stop right there. Questions, please, Matt.
So what I didn't think of what you just said, but what I did was I found G prime and then I plugged it into the integral and then I did it that way, but I got the wrong.
Say it, brother.
But I got the wrong answer.
So you did this. So you're okay with this so far?
Yeah.
Good. What you did is, no, let's finish this one. Don't let me forget to go back to your question. So this would give us a 9 minus 9, that's 0, plus 4, minus 1, plus 3, minus 4. Now that was convenient. Those add to make 0. Those add to make 0. The final answer should be 2. Is that the correct answer? Okay. Here's what Maddie did. 2 points for Maddie. She said, okay, I'm supposed to be integrating out, but F and G prime are the same thing. So what she thought to do was integrate from 1 to 3, G prime, which would be 2x, subtract 3. Is that correct, Maddie?
Yeah.
Questions to there? Raise your hand. If I'm doing it the pink way, what would be my next step? Hands up. Come on, think with me. Don't watch. What would be my next step? Try to get a few more. Remember the slogan. When you can't integrate, anti-differentiate, and evaluate. So what do I do next, Monet?
Anti-differentiate.
So tell me what to write.
So you pull out the 2 and then x squared over 2.
Keep going.
Minus 3x.
Keep going.
And then you would evaluate it over 1 to 3.
Okay, please raise your hand if you knew to do that before she said it. Point 2 for Monet. We want to talk about it. So did you do that step, Maddie?
Yeah.
You're okay, we'll keep going.
With the expanded anti-differentiation, don't you take it, wouldn't it be like 1/2 because there's a 2?
So 2 points for Ariana. Look at your golden notes. Like every time I say look at your golden notes, you really should look at them. I promise, if you get used to looking at the notes themselves, the memories become much more permanent. It's just a fact of life that you interacting, you learn much more than you watching. Okay? As hard as sports sewing is, if all you ever did is watch, you wouldn't learn anything. Fair? You watch somebody sew all day long. You don't learn a bit. You gotta get in there and do it. So look right here. Ariana is correct. If I use the expanded rule, I would have to write 1 over 2. The expanded rule ends up being kind of complex and unuseful if n is equal to 1. If n is equal to -1, the expanded rule is invalid. If n is equal to +1, it's just not very useful. So right here, we've got 2x minus 3 to the first power. So even though I could use the expanded rule, I'm not going to. Did I answer your question?
Yeah, so what rule did you use?
2 more points. I said whenever I have the antiderivative of 2 terms, I'm allowed to take the antiderivative individually.
Oh, okay.
Does that make sense?
Yeah.
It's good work. Your question good? Okay. Maddie?
Does this not work because there's a plus C?
No, you can have the plus C. The plus C will simply add to make 0 anyway. Like some other error occurred, because you got to here.
Yeah.
So now we plug it in. 2 more for Maddie. Here's a common error. Did you put a big parenthesis there?
Yeah.
Another common mistake would have been to forget to distribute. So when you distribute, you get +3.
Well, that's what I heard.
You forgot to distribute. Is that the error? You got -4.
Yeah.
Okay. No worries. So you just made a simple algebra error.
I just don't understand that. Why would you need to distribute?
Let's see. Let's do it over here so the video can hear. Okay, you grow up learning that you should do the parentheses first, which is true, but in algebra we often don't do that. We just use them however. So, everybody in the room, raise your hand if you can tell me what that truly is the same as. Hands up. Don't overthink it. I'm not trying to fool you. Like, what is that? Liv. So do the parentheses first. What do you get? 8. Please raise your hand if you are confident that would be 8. point, 2 for live. If you don't do, if you distribute first, you'd say that's -3, +1. Same thing, 8. If you don't distribute, it's different. I don't know how else to say that, but is that okay?
Yeah.
There we go. Please, have.
I did this like a different way, and I'm wondering if I just lucked out in it working. Because I did that. Like, the 3 I plugged it in. Is that not?
I think that was luck.
Okay.
Yeah, because I don't know how you found. Oh, F is G prime. I got you.
Plugged it in there.
There might be a reason why that works. I have to sit and think about it. Like if you couldn't think of the reason why it worked, you just kind of did something and it worked.
Is that the same as the interval?
No.
Okay.
I have to play. I'm not sure why that worked. I think that was coincidence. Okay.
Thank you.
Everybody out?
Is it okay if you think about it like as the fundamental theorem, and not like necessarily thinking about it as like anti-differentiating?
Uh-huh. Oh yeah, for sure. Yeah, there's nothing wrong with doing this. Saying, okay, when I have to integrate F, you can think of it as integrating G prime. And then you go, oh, the fundamental theorem says that's equal to G of 3. Subtract G of 1. Is that what you meant, Monet?
Yeah.
Uh-huh. 100% valid. 2 points. Please.
We did a different one.
Uh-huh.
Number 17.
17.